Target 7.2 asks you to convert between moles of one substance to moles of another. My suggestion whenever you're doing any type of conversion problem is to highlight the given and highlight what it is that you're trying to find. So in this case, for question 1, I was given 10 moles of C7H6O2, and I'm asked to find moles of H2O. So I was given moles and I was asked to find moles. Even though we see 4 compounds in this balanced equation, you can only work with 2 at a time. So you can essentially ignore the O2 and the H2, or the CO2. So right now, all we're looking at is the C7H6O2 and then the H2O. If you have your foldable book, it would look like this, where I started with moles and I asked for you to find moles. So my railroad will start with the moles given, and then the bottom of my conversion factor is the coefficient of what I was given, and then the top is the coefficient of what I'm trying to find. So we always start out the same way. I'm going to write the given, which was 10 moles of C7H6O2. And then to get rid of that, I need to use the mole ratio. So there are 2 C7H6O2 for every 6 H2O. 10 times 6 is 60 divided by 2. I end up with a final answer of 30 moles of H2O. Question 2 asks how many moles of CO2 are produced when 9.5 moles of O2 react with excess C7H6O2. First things first, this excess C7H6O2, that just means you have extra. You have enough of it. It's not really part of your problem. So I gave you 9.5 moles of O2, and I'm asking you to find the CO2, which means we can ignore the H2O and the C7H6O2. Start by writing down your given, which was the 9.5 moles of O2. Because I started with O2, the O2 needs to go on the bottom so that those two cancel. I'm asking you to find CO2, so CO2 will go on the top. These 2 blanks, those are for your coefficients. There are 15 O2s for every 14 CO2. To solve, I'm going to multiply 9.5 times 14. That's 133 divided by 15. I get a final answer of 8.8666, repeating, so you could round that to 8.9 moles of CO2. Now, if you gave me 8.9 or 8.87, either of those answers would be fine, as long as you include the unit and what compound you're talking about. All right, the last problem, how many moles of C7H6O2 are needed to react with 8 moles of oxygen? So 8 moles of oxygen, that's my given. Moles of C7H6O2, that's what I'm trying to find. All right, 8 moles of O2, that's the given. And then to get rid of that, 15 O2 go on the bottom. And then the 2 C7H6O2, those go on the top. 8 times 2 is 16 divided by 15. I get 1.066, so I could either write 1.1 or 1.07. The rounding is not as important as showing me the work and including the correct unit. So I'm going to just write 1.1 moles C7H6O2. So just to sum it up, in a mole-to-mole conversion problem, you start by writing down the moles of what you're given, and we just call that our A in our foldable book. and then you multiply by the mole ratio. We get that mole ratio from the coefficients in the balanced equation.